Have you ever wondered how scientists figure out exactly how much water flows through a river or stream at any given moment? It is a crucial measurement for everything from flood prediction to water resource management, and it might seem like a complex task, but there is an elegant and widely used technique. The velocity area method is a fundamental hydrological technique used to determine the volumetric flow rate, or discharge, of water in a stream or river. Simply put, it calculates the amount of water passing a specific point over a period of time by multiplying the average velocity of the water by the cross-sectional area of the stream channel at that location. This method is rooted in the principle of conservation of mass, which states that within a defined segment, the volume of water entering must equal the volume leaving, assuming no gains or losses along the way. Water velocity naturally varies across a stream's cross-section, being slower near the bed and banks due to friction and faster in the center and near the surface. To accurately representing this, the cross-section is divided into multiple smaller segments, and the average velocity is measured within each. Summing the discharge from these individual segments provides the total stream discharge. To apply this method in the field, one begins by selecting a straight section of the stream with a relatively uniform bed and stable banks. Next, a measuring tape is stretched across the stream perpendicular to the flow to define the cross-section. Depth measurements are then taken at regular intervals along this transect to define the stream's shape and calculate its cross-sectional area. Finally, a current meter is used to measure the water velocity at various depths within each vertical segment, typically at 60% of the depth from the surface, to representing the average velocity in that vertical. One interesting detail about this method is the concept of a velocity distribution. Water in a channel forms a parabolic velocity profile, with the highest speeds near the surface in the center and decreasing towards the bottom and sides. By measuring at specific points, such as 6/10 of the total depth from the surface for shallower streams or at 2/10 and 8/10 of the depth for deeper channels, hydrologists can accurately estimate the mean velocity for each vertical segment, enhancing the precision of the overall discharge calculation. Understanding the velocity area method provides a critical foundation for comprehending how hydrological processes are quantified. It allows us to transform observable stream characteristics like depth, width, and velocity into an essential measure of water movement, which is vital for managing water resources, assessing ecosystem health, and preparing for natural events like floods and droughts. Mastering this technique is a key step in understanding our planet's dynamic water systems.
If you love learning about water, like, subscribe, and keep exploring with us.